Titans of type and Pythonistas who print, it's Prof. G, and in this lesson we're going to learn several ways to do more with the print command in CircuitPython. We'll cover concatenation, learn more about f-strings, show how to include comma separators in numeric values, right justify those values if printed in a column, we'll show how to include a variable as part of a print format specifier, and we'll work with repeated strings. These techniques will set us up for the Print Like a Plotter challenge presented at the end, and that I'll show a solution for in the next lesson. So stop the presses! It's time for big learning. And now to begin, plug in that Circuit Playground board, Blue Fruit or Express. Start up PyCharm. If you're new here, welcome. You may want to check out the prior lessons in the playlist to see how we got to this point. And I want to start off this lesson in the REPL so we can demonstrate some techniques. So open the terminal, make sure that you're in TO, and Control-C to break any code that's executing, and press any key. You should be in the REPL. You know you are when you see those 3 chevrons, and the NeoPixel lights on your board should be white. And I'm going to drag the top of my terminal up so that we have more room to work in, and we're going to work with some print statements. So let's create some variables first. We'll say first equals, and then in double quotes, Blinka, which is the name of the CircuitPython mascot, that little purple snake, and we'll set last equal to, in quotes, Python. Now we can print those variables by saying print, and in between parentheses, first comma last, and it prints out Blinka Python with a space in between. So when you print variables or expressions using print and you have a comma separating the variables or expressions, it adds a space in between. Now we can also do this, print, and in between parentheses, first plus last. And it doesn't matter if you have a space between the plus and the variables. Make sure you're consistent. I think it's a little bit more readable if we do add a space on both sides of the plus. But when you press return, we get Blinka Python and no space in between. So what the plus sign does when applied to strings is it joins them together. No space in between. This is called concatenation in computing. So the plus character when applied to strings is not arithmetic, it's concatenation, which joins strings. Cool. Now we can also use f-strings, and in the REPL, unfortunately, it doesn't type the corresponding closing character when you type an opening character. So I'm going to enter print, open, and then closing parentheses, and then move back to the middle. I'll say f, open double quote, close double quote, and then in between the double quotes, I'll add one set of open and close curlies, space, another set of open and close curlies, and then in between that first set of open and close curlies, I'll put in the variable first, and in between the second set of curlies, I'll put in last. Notice I've got a space in between those 2 sets of curlies, and that space is inside the string because it's closed in between the double parentheses. So when we press return here, we get Blinka space Python. That space comes from the space that you see here in between the 2 sets of curlies. Now you can put any additional characters around the curly braces that you have in an F string as well. So if I up arrow here and I want to make a modification, for example, inside the double quotes, if I want to put ms period space just in front of the curlies that hold the first variable and press return, and we get Ms. Blinka Python. Cool. Well, let's start working with integers. Why don't we pretend that we got a sensor value in a variable here, sensor underscore value, and we'll set this equal to 50,000. Don't type a comma in here. In Python, a comma separates 2 separate values, so you don't want to put that in your number. You want to write the number out whole. No additional punctuation. But we'll say below, print, and in parentheses, sensor underscore value. It prints out 50,000. That's what we expect. Now we can also print this value inside of an F string, although if we do it, it doesn't add a lot of value. We could say print, open and close parens, and then inside this F, open and close double quotes, and open and close curlies, and put sensor underscore value in here. Press return, we get 50,000 again. But here's where those F strings can get a little magical. Press the up arrow, that enters the last line that we executed, but we can use the left arrow key to go over here and make a change inside the curly braces. After sensor value, I'm going to put in a colon and then a comma. Press return and see what this does, and ho-ho! It adds comma separators in my number. Very cool. The colon followed by a comma is a way to enter what are called string format specifiers in Python. There are a bunch more. CircuitPython implements most of the string format specifiers, but not all of them. But the colon comma after a variable between curlies is very useful. You'll want to keep that one in mind. Hey, why don't we see what we can do with a list of numbers? Why don't we call this list numbers and set it equal to, and in between square brackets, 50,000, comma, 1234, comma, 0, comma, 27, comma, 291, comma, 51, 515. So we got 6 values in here of different lengths. Now remember, we can loop through these numbers in the list by iterating through them. We can say for number in numbers, colon. Remember what happens in the REPL, we're indented here with 3 dots. Then we can say print, and in between parentheses, number, and that'll get each individual value of the list. So press return, delete return, and it executes, and we see a number on each line. Now let's try this again with the string formatter. So I'll use the up arrow to find the for number and numbers line, press return, I get my 3 dots. I can also use the up arrow to get the print number line, but then I can modify this line so it turns into an F string with F, and then I'm going to surround number with double quotes on the outside, and then inside of that, curly braces. And then I'm going to add that string format specifier with colon, comma, inside of the curlies after the number variable. Press return, delete return, and look at that. Now we've got our numbers formatted nicely with comma separators. Now the commas are cool, but the numbers are left justified. Sometimes you want to right justified numbers. Let me show you how we can accomplish this. First, let's create a variable called sensor_max, and we'll set that equal to 65,535. I created mine in all caps. It's up to you. This is the maximum value for the light sensor, and the reason that I put this in here is you can pretend that the 6 values in your numbers list are all readings from the light sensor. Typically, if that's the max value for your sensor, it's never going to change, so all caps are a good convention. But let's count up how many digits we've got. So there are 5 digits in 65,535, and then if we add one more character for a comma separator, then that would be 6 characters. We'll watch what we can do with our list. We'll say for number in numbers, colon, press return, we're indented, and I'll say print, open and close parens, F, open and close double quotes, open and close curlies, then I'll have my number variable inside, then I'll say colon, and watch this, I'm going to say 6, and then comma. The 6 means that the numbers that I print should take up 6 characters, and if they're less than 6 characters, I'm going to right justify them with a space as a filler in front of them. Press return, delete return, and whoa, look at that! Right justified with commas, nice. Well, I just hard-coded a 6 here, and I could do that because I knew the size of my largest sensor reading. It was going to be 65,535, add a comma, there are 6 characters in that value. But what if I wanted to calculate this anytime I change the maximum sensor reading? Well, one way I could do this, the way I could calculate this automatically, actually not this way, I made a mistake, I forgot the F in my F string. When I do that, it treats everything inside of the double quotes as a string. That's why I get 14 as my value here. Let me up arrow, so this line should be length equals len, parens, F inside that, followed by double quotes, then curlies inside the double quotes, then the variable name sensor_max, followed by colon and comma. Press return, then I'll print that variable length I just created. This prints the length, and this is 6. That's correct. So if sensor_max was a different value with a different number of digits, the length would be calculated appropriately. And the advantage as a programmer is I just have to change one value, my sensor max, rather than 2 values, the sensor max and the length of the string with a comma in it. This makes my code easier to maintain. Is that a big deal in maker projects when you have a small amount of code? Maybe not, but it's a good programming practice for larger programs. Now let's see how we might use this new variable that we just created, length, in our loop. So I'm going to enter for number in numbers, colon, and on the next line, I'll pull up my print statement with the 6, colon, comma. But let's try this. We'll replace 6 with the name length, which is the name of the variable up above, and it won't work. Return, delete, return. This says invalid format specifier. So the reason we're getting this error is it's looking at that word length as a format specifier and not as a variable. Well, how do we change this? Let's pull up our code again. First the for line, then the print line, and we simply wrap this innermost variable length in its own set of curlies. So the first set of curlies gets the value for the number, and then the second set of curlies is around the length variable that's going to get the value for length and use that as part of the format specifier. Return, delete, return, and we get the same results, but our code is more flexible. Very cool. So that's format specifiers and using variables inside of format specifiers. Now another print trick is using the asterisk or multiplication symbols to create strings of repeated values. Let me show you. Let's say print between parentheses, then in double quotes we'll include the single character dash. That's the string we want to repeat. Then we'll follow this outside of the double quotes. Star for multiply and 10 to repeat this 10 times. Make sure that you've got a closing parenthesis here. Return, and oh, look at that. We have output with 10 dashes. Cool. And you can do this with 100 dashes. See that? Or really any integer value, just no decimals here. Now let's use a for loop to print a triangle made up of increasing numbers of star characters. We'll use the for loop like this. For I in range, and in between parentheses we'll pass in the 6, colon at the end. Then indented on the next line, we'll say print, and between parentheses, double quotes with the asterisk character in between the quotes. So it's a string here, it's between double quotes, it's not the multiplication symbol, but we follow this with an asterisk outside the double quotes. That's the multiplication symbol, followed by I, the value we're going through in our range, close parens, return, delete, return, and we get a nifty set of stars in increasing row lengths from 1 to 5. Cool. Now, the reason we're going through all of this is to figure out how we can create print statements that mimic plotter output. So let's set up some variables that we might create in a program where we want to set this kind of output up for any type of sensor. So first, let's create a variable sensor underscore max. I'll put this in all caps. We'll set it equal to 65,535, which is the max value for a light sensor in a circuit playground. And then we'll create another variable for the length of the line. So I'll say line underscore length in all caps. And I guess it really depends on your font size, but I'll say 90 here. And then let's create a variable that will pretend just got a sensor reading from our light sensor. So we'll call this sensor underscore reading, and we'll set it equal to, for now, 50,000. Now with these three variables, how can we print out a line that's a bunch of space characters with an asterisk after it, where we adjust the number of spaces based on the value of our sensor reading? So it should look like this, with the asterisk seeming to move left and right. So the question is, how many spaces do we need before we print an asterisk or a star? Well, one way we can do this is with some middle school algebra. We'll calculate a variable, why don't we call this spaces, and we'll set this equal to the equation of sensor underscore reading. That's the variable that's going to change. And we multiply this by line length divided by sensor max. So that's going to be the recalibration of whatever this value would be based on the 65,535 scale to a 90 character scale. So when we set this up, and then let's return, and we'll print in between parentheses the spaces variable we created. So on this scale, where 65,535 is recalibrated to 90 spaces, a value of 50,000 would have 68.6656 spaces in front of it. All right, let's see what this would look like if we printed it out as a single line. So we can print between parentheses a blank space between double quotes, then times as a star, and then we'll use the spaces variable in here, but we're going to get an error. So this first part calculates the repeating string of spaces. Then to the end of this, we're going to concatenate, or we're going to add with a plus sign the string between double quotes, star, or an asterisk. Close with parens, press return, and ooh, look at the output. This says unsupported types for mul surrounded by two underscores, str float. Well, we can read this even though it looks a little cryptic. Mul stands for the multiplication symbol. Str is the string, our single space up here. And float, remember that means a number with decimals in it. That's our spaces value. Oh yeah, we printed it out up here. It's 68.6656, but we can't use a float to create a repeated string because we can't create fractional strings. We need a whole number, we need an integer. So how do we fix this? We convert the value in spaces to an int by putting int in front of spaces. That int is in lowercase. And then we surround spaces with parentheses. So this is going to take whatever variable is in spaces and convert it to an integer. Now we can print this out. We see we get 69 characters before we add a star. So this is what we'd expect from an output line. Very cool. Now, when you're writing code, it likely makes sense to create separate variables on different lines because they're easier to read. But since we're working here in the REPL, why don't we try to put everything on one big line so we can continue to just up arrow and repeat this. So we'll say print in between parentheses, then our string to repeat, which is just double quotes with a space in between, star for multiply, then int between parens. And then what we want to put between parens, we'll go up here and we'll grab this equation we used to calculate the spaces variable, and we'll paste it between the ints parens. And I've got an extra space in here. I'll get rid of that. Spaces don't cause errors, so use them in any way that you think makes your code more readable. So if you want them before parentheses, you can do that. Otherwise, you can get rid of them. But you know, we should make one change to our formula. Since we have a maximum of 90 characters, but we're adding a single character to the end of the number of spaces, that's the asterisk character, then we should actually subtract one from line length before dividing it by sensor max. This will make sure that we've got one extra character at the end for our asterisk mark, and that we don't go over our 90 character limit, which is our line length. Make sure line length minus 1 is within its own set of parentheses. We want that to be calculated before we divide it by sensor max. Then just before the closing parenthesis, we want to concatenate, so we'll add a plus sign, followed by in double quotes an asterisk. And it's always good to take a look at the line to make sure that any characters that have a match have that match. So double quotes match up, parens match up, looking good. Press return, we get the same thing. The star is actually one less number of spaces because we added the minus above, and that's what we wanted. Cool. Now what would this look like if we set sensor underscore reading equal to 20,000? Press return, and then we'll up arrow to get our big print line that we created again, and press return, and look at this. This only has about 40% of the spaces of the 50,000 sensor plot above. Very cool. What if we change the sensor reading to 1 and reprint the plot? Oh, no spaces here. The star is to the far left, and that's actually what we would expect. Hey, how many values of the sensor reading on the scale of 65,535 as max equate to a single space? Well, we can calculate that with sensor underscore max divided by, between parentheses, line underscore length minus 1, close parens return, and this gives us a fractional value just above 736. So in this case, if I change sensor underscore reading to say 738, and then run the print plot line again, I can see a single space in front of the star, so this is working as we'd hoped. Nice. Now you can try some more values, so we can try 0. We don't expect any divide by 0 errors. It's a good idea to try the extremes, though. This is the same output as reading 1. We'd expect it to be at the far left. What if we had the max value, 65,535? If you counted up the number of spaces, there should be 89 there, plus the star at the end to reach the 90 character scale. So this is great. And now with this knowledge, I want you to tackle the print like a plotter challenge. First, let's Control D to get out of the REPL, and we can close up the terminal. And here is your challenge. So you should write code to replicate the vertical running plotter that takes a sensor reading and its maximum sensor reading value and converts this on a scale based on the maximum number of characters that you want to print on a line. You can continue to use 90 if you want to, but you don't have to, and the result should look something like this. Now, I'll mention how to set this up. Configure your build with the following variables so we can best compare results. So sensor underscore max should be the maximum value for the sensor. That's 65,535 for the light sensor, and I want you to use your light sensor for this build. You can also assume that the lowest value is 0. If not, you'd have to adjust your math for the new lowest value. Now line underscore length should be the maximum number of characters in your TO output. Again, this varies according to font size, but I'm going to use 90 for my solution. And then sensor underscore reading is the variable that you'll capture from the repeated sensor reading. Again, use the light sensor reading for your solution. Now for each sensor reading, you want to print out a plot line which has the star plotted to represent a sensor reading on a line of maximum character length of line underscore length. Now this is going to involve converting the scale for the sensor max to the line length and using this to identify where on a line you should print the star, prefaced by a certain number of spaces to calibrate on your new scale. So far this is pretty much what we've demonstrated, but for part 2, on the same line as the plot, I want you to precede the plotter output with a right justified numeric sensor reading and use the format specifier so that a comma value is included there for easy reading of the number. Now note in the sample output how values are at the far left, but they're right justified with a comma in them. That's what your output should look like. So think about how many characters you need on the left-hand side, and this is going to influence how many characters you have left to print your line without going over line length. Then for part 3, you want to try to make this reusable. So put the code into a function called print underscore plot that accepts a sensor reading. You can call that sensor underscore reading as well if you'd like, and it prints a single line with the numeric sensor value at the left, formatted appropriately, with the numbers themselves right justified, and the plotter line should follow it in the function. Wait 0.5 seconds in between each call to plot print so that the results don't overwhelm your printed output. Then save your program as plot-print.py. Here's one more reminder of what the solution will look like. Check out how we have sensor values on the left. Those values are right justified. We got the commas in there. The plot is over on the right. Cool. Feel free to rewatch parts of this lesson if you need some extra help. Here's a summary of the big learning in this lesson if this crib sheet is useful for you. Give this a shot. We won't bother to pause here because we'll show the solution in the next lesson, so commence the challenge hacking, and soon we'll compare answers. Good luck!